what I will do here is a quick walkthrough of Breeze and Breeze Runtime. So I will actually use an example that was mentioned by Julio earlier today, looking at strawberries. So this will, of course, be a very, very quick kind of walkthrough of the software. I won't have time to show you all the features because there's so much to show. But it will be a quick demonstration of how easy it can be to build and run a simple application. So I will go through the data acquisition, to do a quick quality check of the data and the spectrum of images, apply segmentation to segment out the strawberries from their images, add the training data. So this is the Brix value, which is sugar content. And then I will train a quantification model that can then measure the Brix value from the hyperspectral data. And then I will develop and run a workflow and demo that kind of continuously from real-time data. So that's what I want to show you. So I will open up the software here. So you should now see that on your screen, the Breeze software. So what I said, like I said, I want to start with doing data acquisition. So here are some, let's say, projects that I have started already. So I'm going to open a project, and I'm going to open this project here. And then I'm going to press on the recorder. So now I'm going to do a data acquisition of data. So this is what that view looks like. So first thing you need to do is, of course, connect to your camera. Now, I don't have an actual camera here, so I'm going to use our camera simulator function in the software. So here, if I actually had a real camera, it would actually be available in this drop-down menu. So now I'm going to use the simulator, and I'm going to use a data set that's already been pre-recorded in my project. So I'll press the connect. Then it should connect to that. All right. And then before I, of course, do my data acquisition, I could adjust some settings, like how long should I scan? Should I give it a specific name, this image? Should I adjust maybe the integration time or frame period? But I'm not going to change anything like that here. I'm just going to press the record button. So then it should start scanning. All right. Okay, I'll just stop there. So this was a very quick scan. So these are the strawberries I just recorded an image of. This is a pseudo RGB image. You can also get a view, let's say, of intensity. So here we can see the signal intensity of the data we recorded. We can also do a quick check of the actual spectral data that we recorded. This, of course, can be quite nice, let's say, quality check of your data to make sure it looks good. So here we have the RGB image. Here I can move the mouse around. I can actually look at the different pixels. I can select the pixel or a few pixels to compare, like this, right? Or I can select an area, the freehand selection, to get an average spectra for a region, right? So if I have taken a white and dark reference as part of my data acquisition, then I can quickly just check the actual calibrated reflectance spectra here in the software. Or I can, of course, check the uncalibrated spectra if I would like to do that for some reason. So this is a very nice tool. Yeah, so that was a quick demo of the data acquisition. So now let's, I'll leave this project. I'll go to a different project where I want to show you now the data analysis. So I'm going to open this strawberry project here, and I'm going to go to the analyzer. So first, what you'll see here is we have on the left side, we have this structure of folders. So we have the project called Strawberry, and then we have in that a number of groups, which basically are folders with a number of images. And you also have a table view here on the side, where you can actually then see the a thumbnail for each image. I can click on that here, and then I get a enlarged image. Yeah, I can also now, let's take a look at each one of these images in a little bit more detail. So here we have the, let's see if I can move this window from Teams. Okay, here we go. So here we have an RGB, pseudo RGB image. As I showed you before, you can move the mouse around, and you can actually kind of in an exploratory way, look at different spectra for different parts of your image. This is a pseudo RGB image that you can adjust the bands for. So here you have the red, green, and blue bands that are being used, and you can actually slide that over to adjust in real time the image to highlight certain parts of the spectra. You can also use the single band image. And I was just looking at the intensity in one individual band. And you can kind of see if there are some particular band where you have some parts of the image that stands out. There's also kind of a nice exploratory tool. Another nice thing, a very useful tool in the software is to do a PCA analysis here. I'm going to create a PCA model. Okay. So this has now created a scatter plot down here. So each blue dot here corresponds to a pixel in the image. And this PCA is a really nice way to visualize the kind of clusters or groups of pixels that we have in the data based on the spectral similarity, right? So if I select some pixels here, I can see where they are clustering here in this scatter plot. And then I can actually use this as a way to select. So here we have a cluster of pixels. If I select that, it will then also highlight that in the actual image. And then I could say, okay, this is the part of the image that I'm actually interested in. So I only want to include those. Okay, we get something like this, and then we could maybe improve this a little bit more to clean it up. And there we go. It's okay, I guess. Here we have now segmented out those strawberry pixels from the background. Okay. Now this is really nice, of course, but and it could be useful if you're looking at a few images. But if now we have a bunch of images here, we want to apply this segmentation to. So what I'm going to do is create a PCA model that I can apply to all my images in just one step to do the segmentation. So I'm going to go to press the model button over here. So I go to the tool where I can make models. So here we actually have a menu on the left side where we can see existing models. So we actually have already a segmentation model, a PCA model, and we have a bricks measurement PLS model. So, but I'm going to show you just briefly the step I'll go through to make such a PCA segmentation model. So I will select this button here to make the model. Okay. Okay, and then we have here a list of all the images. So I'm going to use a few of these to make my PCA model, right? To train the model, I should say. Here we can see the spectra we want to use for training the model. Okay, I'll go through next here. And then now you have actually a mosaic of those images. And it has applied the PCA on that, right? So we can kind of use the same procedure as I did before, but now it's applying it to all my images here. So I'm just going to select it like that. Maybe clean it up a little bit more. This looks quite good. I think now we have kind of defined the pixels that are part of the strawberries. And then we can set a threshold to basically for what pixels should be included or not for the segmentation, right? So I will cancel here and I will show you. So the next step you go through and then you finish this and then you actually get a model. So I'll show you what I did before. I got this kind of result. Looks quite good. So now I'm going to apply that PCA model on all the images in this project. So I'll go back here. And so what I want to do here, I will open this here again. Now we'll press this Analyze Tree tab out here. So this is where you make your data processing workflow. So now, of course, it's pretty empty here because I haven't done it yet. So for the image, I will press a plus sign here, which then adds a new node in my analysis tree. So if I do that, I get this menu where I can select different types of tools. So we have like segmentation tools. So you can see there are a lot of options here. You can use a model. That's what I'm going to do in a minute. But you could use other tools like deep learning segmentation, segment anything. We have lab Python script and so on. So there are a lot of different tools that you can use. Now I'm just going to show you how to use a PCA model for this. I'll also just briefly show you the descriptor tab. So here you have a bunch of different other tools. So descriptors are basically, let's say, parameters that you want to calculate from your images. So this could, for example, be a classification model or something like this. And we're going to actually apply a quantification model later on. And it could also be applying or generating different statistics from your output from the model. So for example, it could be, let's say if I done a classification, I can then also say, well, I want to know the percentage of pixels for each class in each object. Then you can also add such a descriptor. So it's not just model output, it's also like statistics or even some visualization tools that you can add to your analysis tree. So, but like I said, we're going to do segmentation now. So I'm going to select the model option here. And here we now have this PCA model that I made. And we can also set a mean area. So what I'm going to do here is I don't want to have, if there's some dirt or some dust, little particles or objects in my image, I don't want to segment out those, right? It could be part of the leaf that fell off or something. So I'm going to set the mean area of 400 pixels. So anything under 500 will not be segmented out. Okay, that looks good. Then we can apply this to a project here, or sorry, a folder of images. So I pressed apply changes, and then it applied that to this image. And now you can see in the table, we actually have segmented out these objects. And as you can see, it's linked, so I can click in the image or I can click in the table. Yeah, let's see. So now I think this looks quite good. I mean, I can scroll through. I've applied this on this group, and let's apply it on also on this group here. You can, of course, apply it in just one image to test, and then you can apply it on a group of images or all the images in one step, depending on where you are in this menu here. Okay, so this looks quite good. We've segmented out all the strawberries here, and you can switch between different levels of segmentation. So you could go back to the kind of level where you look at the whole image, or you can go to the segmented level like this. Okay, so that looks quite good. Now what we're going to do, we're going to add the bricks value for each strawberry. So I guess this was measured with a lab test, and this is going to be useful then now for training a calibration, right? So we're going to model those bricks lab values with our hyperspectral data to see if we can make a model. So you could just copy paste this from a spreadsheet, let's say. You can manually write it in, or what I'm going to do, I'm actually going to import a spreadsheet. So I go to the import option and variables and ID data. Okay. Right. So now I'm going to select CSV file, this one. So basically, I think I have it here. So basically what you have here is the measurement. So this is like the sample ID, right? And then you have the bricks value. Now this is just a comma separated, right? So you have the measurement ID and then comma 8, which is the bricks value for this particular strawberry, right? So I will import that data, and then I will use this segmentation step, and I will include these two columns. So now we'll actually, it will make sure that the right bricks value is associated to the right strawberry, because it will actually, because I have this measurement name both in the Breeze software and in the spreadsheet. Okay, so let's press finish. So now we just imported the bricks value here. So we can scroll through. If you click on it here, you can then get it will kind of color the object based on the bricks value. Now it goes all the way up to 100, which is a bit excessive. Let's try 15 to get a better scale. And we can even sort objects by their value. So here we have a high bricks value, and here we have a low bricks value strawberry. So what we want to do now is also then, we want to use this information to make a calibration. So what I want to do is actually, I'm going to go to the, show you this, I'll go to this Explore tab. So basically here, what it's doing, it's calculating out an average spectra for each strawberry. So you can click on a strawberry, you can actually see the spectra here. Here it's a PCA scatter plot, but it's not on the pixel level like I showed you before. Now it's on an object level, right? So I could, for example, select a high Brix value strawberry. Here I can see the spectra and compare it to a low Brix value strawberry. And I can see in this case, there are some spectral differences. And that's what we want to use for making the model. So what I will do here is I will go to make a model for this. So I'll press the model button here. I will press add and quantification, and then I will select to do a PLS model. Okay. So this is the segmentation we want to use. That's fine. Here we have all the strawberries we want to use as our training set. So we have 100 strawberries in this case. We have the spectra here. So I think Lucas showed you, you can actually then use this to select part of the spectrum that you want to include or exclude from training your machine learning model. We have this variable importance plot, which is quite useful, that highlights those part of the spectrum where you have the most relevant differences, in this case, to measure the Brix value. So you can actually sort also this to see where those are. Okay. There is also spectral filters you can apply to the data. So now we have, if I just remove everything, so this is what the kind of raw data looks like. And then if I apply the scatter correction, S and V, it kind of tightens up the data a bit and removes some of the scattering effect. We also have some smoothing and derivatives and other tools that you can use on your data before you actually feed it to the model. So I think that's okay. I'll use the spectra like that. I'll skip ahead here. And then it has now generated a PLS. So you have a kind of a calibration curve here for this regression model. And I guess it looks okay. You have a root mean square error for the calibration set of 0.48 Brix units, which I guess is okay. You also get a kind of an R square and Q square value here for this model, which I use for statistics. So I think I can just finish this one. Then it trains the model. It's very, very quick. And now we're going to use this model to analyze our images. So I'll go back to the analyze tree, and then we will add a step here. So I'll press the plus sign. We'll add a descriptor, which is the quantification of properties, the Brix value, and I'll apply a smoothing function here to smooth out the image. And then we can just test it on one image to see what it looks like. I press apply changes. So now it runs that PLS model on all the images. Alrighty. So here we have the output. So here we have then the Brix value on the pixel level, let's say. And also we can check the average Brix value for each object. And you could also right click to get a scatter plot, or you can get a histogram to view the results. So I think this looks quite good. Now let's run this as a continuous real-time analysis using the camera simulator. So what we will do first is we'll actually export out this very simple workflow. So I'll go to the export function and click on export to Breeze Runtime. Okay. And then it will save this in an XML file. So I will press next and finish. Now it has exported that. So then what I will do is I will close down. Breeze here. Okay. And then I will open the Breeze client software that I mentioned before, which is a simple GUI. So now, of course, like I said, I don't actually have a camera here, so I'm going to use the camera simulator. So I'll go to the settings, and then I will connect to an image that will read from my hard drive. So I have this .raw file here, which is a hypercube. I'll press connect, and then we'll just connect to this one. All right, that's it. So now it's pretending to be connected to a camera, right? Now what we want to do is open our other software called the Breeze Runtime demo. So let me open this guy. Okay, here we go. So this software has some very simple GUI with some buttons, basically send commands to runtime. For example, loading different workflows, taking white and dark reference, start-stop prediction. You could even tell it to start recording the raw data, the spectral data during the prediction. So what we're going to do here, we're going to load a workflow. So I'll select the workflow we just made here. Okay. I will initialize this, and then I will start predicting. Now it will run this workflow, right, that I showed you before. And you can actually now see the data being sent. So you can actually see the communication here from that's calculated. And of course, now we want to visualize that. So I will go to the Breeze client program here, and I will press connect button here. And here we go. Now we have the results coming out. So we have now for each strawberry, we are reading the data, right, continuously. We are calculating the bricks value. And we also have in this software, each strawberry we are processing, it will send this information out. So here we have, in addition to the bricks value, we have like timestamps for when we analyze the objects. And we can, of course, calculate other things like where is it in the image and things like that. So this is, of course, a very nice tool if you are a developer and you're working with the integration of runtime into your system. So I have this software here. Okay, that will conclude my software demonstration.